I'm like having class that stumps me because I took business calculus last quarter and I did okay, but statistics wrapping my head around it is so hard for me. I don't know
Well,
how.
it's just different, and it's a little bit more. Um, this stuff that we're doing right now, I describe it as a bit more like a lawyer got involved. So you have to do things a very particular way. So we have a story,
Yeah.
and that story at the top is going to generate what's called a null and alternate hypothesis. And then we have all sorts of things that we're going to do, typically get a test statistic and a p-value, and then we make a conclusion. And so the whole process from start to finish, and it's got a process, right? You do this, then you do this, then you do this, and then you finish. So if you can
Yeah.
follow the process, you're good. So what's this story? In 1990, ear piercing and tattoos became common among college men. Okay. Surveys of male students at a large university during that time period found that the following numbers of the 425 men with no pierced ear. Let's read that. Of the 425 men with no pierced ear, 44 had a tattoo. And of the 143 men with at least one pierced ear had a tattoo. Okay, so you're comparing two groups here. One is pierced ears with tattoos and one pierced ears, right? Without it, right? Okay, so that's our population. Assuming that these men represent college students in the 90s, test a hypothesis that college men with at least one ear pierced were more likely to have a tattoo than those who didn't have their ears pierced. So, okay. And they say, let one be the college men with at least one ear pierced, and number two, population two, be college men with no ears pierced. The trick here is to kind of imagine this information and then kind of write it down in the language of hypothesis test. So what I see is two populations. One of them's proportion is P1, the other is P2. So the null hypothesis is always going to be the same when you're comparing two populations. Can you remember what the thing should be?
Is it P1 minus P2 equals 0?
Yeah, every single time, because what that is saying is that they're the same. There ain't any difference between people who had ear piercing getting tattoos and those who didn't, right? And then the alternate depends on this story, and it depends what you're trying to prove here. So
I think this one's more likely.
More likely. Now, is the people, let's make, because sometimes they're really sneaky here and they switch places in the story. So they talk about men and women, but later on they call, you know, women come first, take away, men come second. So we have to be really careful that we get the ones and twos right way around. So in this story, who is one? Do they have an ear piercing or not? If you're number one.
I'll use college men with ears. So I guess it would be the second way around. So would it be?
Well, who are we going to call one and who are we going to call two? Now, I'm not saying this one is switched around. I'm just saying be careful because sometimes they do switch it around. It doesn't mean that they do it to every question.
Okay. Well, number one will then be the ear pierced, and number two will be no ears pierced.
Right. So, ear pierced, take away, no. Do you see it in that bracket there?
Yeah.
Right. Here. So, right. As long as you stick to that order, you're going to be fine then. So that means if you've got an ear pierce, you're going to be P1. And if you don't have any piercings, you're going to be P2. And we're trying to prove that guys with it are going to be more than ones without. So we're good to that point. So that is the first stage, set up the null and alternate. And it's a lot of information with a lot of numbers and a lot of this is bigger than that going on. So you kind of just have to be careful and set the thing up. Because if you do the first bit right, the rest tends to flow a lot smoother. Now, the next bit is a quick check that we should be doing this hypothesis test in the first place. So there are two independent samples, true. And we're told that we'll hit the select button. and see what our choices are. We can, so we're picking that one. They assume that they're randomly selected. Because if they're not random selected, then stop there, don't bother doing it. Right. Now, there's a guy here called N1 minus P hat, and both at least 10. Can you remember what you need to do about N1 minus P hat? What is special about that guy? It's called it. I call it the 10
should know the answer
test.
to that, but
Right. Well, I call it the 10 test. And basically, you've got to have at least 10 people who say yes and 10 people who say no. So let's hit the select button and see what the choices are, because it should say are. There we go. And are both at least 10? Are
how,
they? Yeah,
so
they
does
are.
that mean that the statistic, so you're saying that 44 over 425 people, at least 10 of them do not have their ears pierced, and out of 43 out of 140?
We're saying that.
43 out of,
Yeah. And we're also
Okay,
saying it
that
the other way around, that at least 10 of them do have piercings as well. So we can
okay.
include that the thing is met. So that's that bit over with, once you can. Now, the next bit is much similar to what we did. We're going to hit salt, and hopefully you've got all the numbers you need, or at least you can go back and get them.
Yeah.
So
So now it's
two
just kind of like
people-
what we just did.
just the same idea, but plug in the numbers where the guys with piercings go in first, and the guys that didn't have piercing go in second. And we're trying to prove that that's always zero. We're trying to prove the first thing is bigger than the second, aren't we? Right, and then generate results. And there's your test statistic. And your p-value is virtually zero, isn't it? It's tiny.
Can I just type in 0 like that? or
I
does it have
would.
to be 0.00?
Technically 0.0000, but I think it should take 0.
Okay.
Right, now, kind of same finish as before. Isn't this p-value 0? Significantly level, right? So the p-value is less than, which it is. 0 is less than almost everybody. So we reject H naught again. And we finish with there is sufficient evidence to conclude blah, blah, blah.